Good afternoon, class. Today we're going to be looking at the elements tree in Windows Presentation Foundation and some different ways that we can utilize it to make our lives easier as WPF programmers. So as a starting point, we have this WPF application for a simple calculator, the same kind that you would have used probably back in elementary school, where we have the 10 digits plus a clear button plus the minus, multiply, divide and subtract and equals buttons, and really nothing more complex than that. Once more, this is just an integer calculator, so it's only going to deal with whole numbers. And we've also written some of the backend code for this. What we're going to be focusing on for today is really just the elements that tie into that concept of the elements tree. Now, this is also a single window app at the moment, so everything is defined in this one window class, the main window. And we have, of course, the grid is our main layout element, and it has children, which are the buttons, and the text box, where the actual value of the number that we're currently entering is, as well as the buttons for all the different operations. Finally, this window itself is technically a child of the app.xaml. If we take a look at that, we can see this startup URI corresponds to that main window XAML. So that's what this application is going to open as its main window. Now, what we're going to be focusing on today is kind of different ways that we can do things a little more easily in WPF. So kind of building off of what we've been doing before, maybe what we want to do is restyle this calculator to look a little bit better. So to start with, you'll notice that all the text is pretty small, and especially like if we look up here at this text box, we probably want to make that a bit bigger. So one of the things we would do to do that is we normally would go in and start setting some properties. In this case, maybe font size, and we might set that to be a much larger size, maybe 50 pixels. And normally these calculators, that would be right aligned, so we might change the text alignment property as well to be right, so that it's going to sit on the right side. And that's a good start. I'll probably also want to make all of the text on these buttons larger as well. So we could do the same thing for the buttons, but the drawback on the buttons is if we look at them, there's quite a lot of buttons to add rules to. And yeah, we can copy paste them, but we really always want to be a little shy about copy paste because that can lead to some pretty common errors, and if we can avoid it, we want to avoid it. And also, it'd be nice if we could change the font size on all the buttons at the same time. Now, it just happens that there is a way of doing that in XAML, and that's done with a specific resource. Now, resources are actually a property of all XAML controls. In fact, if we jump back to the app, notice that we have application.resources here, and it takes a collection, so we could just start putting tabs in there. But we could also do that at the main window XAML. So we could add resources to this main window, or we could add it to the grid, or we could add it to any of these controls down here. So all of these objects have a resources property. And when we declare something in that resources property, it is available to that element and to all of the descendants of that element in this elements tree. So everything that's nested inside of that element also has potential access to those resources. So usually, if they are some kind of resource that's specific to a specific control, we would put it in that control. If it's specific to the entire application, we'd put it in the application.resources. Let's go ahead and attach ours to the window. Since our whole app is a window, then we can just declare, again, a resources property for the window, and because it's a collection, we do it as this breakout style of property where it has its own element. And then we can declare different kinds of resources in here. And one that we might want to declare is a style. This is kind of like declaring styles in CSS, if you've worked with HTML and CSS, where you have kind of a property you want to change and the value you want to change it to. To do that here, we would actually use a setter element, which again has a property just like CSS, and in this case font size is what we want to change, and a value that we can also set. But the big difference is, or and similar to CSS, when we set up some rules, we also need to identify what those apply to. Now, because XAML is actually working with C# objects, what we're actually going to use is a target type, which says the type of the object that we want this to apply to. So we might make this, for example, apply to button. And when we do that, notice that all of our buttons now have much larger text and looks a lot better. And that was just a very, very simple change. Now, that's not the only kind of resource we can have. We can also create media resources. For example, in this images folder, we have this mountains JPEG, which is an image of a mountain scene, and maybe we want to use this as a background or a skin on this calculator. So if we go ahead and go to its properties, notice that we have the build action set to none currently. We can switch this to resource. And what that means is that we are now going to compile this into the binary of this project, so either the DLL if this is a library project, or the executable if it's an executable project, and that's going to make it available to us in our application. So this is different than when we set it to content previously and we said that we were going to copy that to the output directory. In that case, we have to distribute the files, the image files, along with the executable in order for them to work. Here, we're actually putting it into the executable itself. And by putting it there, we don't have to copy extra files when we distribute this application. Now it's just there. So let's go ahead and add a resource that would, or a resource that would access that image and make it available to us. And in this case, this would be a bitmap resource, or bitmap image is the type of resource we would have. And we give it a key, and the key is an identifier that we can use to access this resource later on. So I'm going to call this one mountains. And the next property we're going to do is Uri Source. So this is a universal resource indicator, and this tells us where that is located. And in this case, it's basically the path that we have defined over here in our Solution Explorer. So images/mountains.jpg. Images/mountains.jpg. And now we can use this resource elsewhere in our project. So for example, we might want to make the grid's background be that particular image. So we would want to go ahead and say grid.background. And again, we're going to use a breakout property because in here we're going to have to declare an image brush. And an image brush needs an image source. And we want this image source to refer back to this bitmap image. And the way we do that is first we go ahead and add some curly braces within the double quotation marks. And then we're going to say static resource. And then we're going to identify the static resource that we are using here, so mountains. This is technically a form of data binding. We're going to talk about data binding in a little while, but for now you can just know that if you set static resource inside the curly braces and use the key of a static resource, you are binding that property to this static resource. So now we've set the background of our grid to be that mountain. Now, it doesn't really look like we did anything because we can't see it. It's all covered up with buttons. So one of the other things we might change about our layout here is add another setter and go ahead and set property equals, and we'll set this property to be the margin property, and we'll set its value to be maybe 10 pixels. So we're going to pull everything back 10 pixels. And when we do that, oops, I need to spell margin correctly. As soon as we do that, notice now we have 10 inches around all these buttons and we can start to see that mountain behind it. So now we're maybe just, you can think of this as adding a skin to this calculator, making it look pretty. We still have, of course, this text box also has that great big stretch to the edge of the margins. We probably want to add a margin to that as well. And there's actually a way that we can take this style and have it apply to both so that we don't necessarily have to repeat it. It does take a little bit of difference in how we set this up because we basically have two target types that we want to target, and we're not allowed to have more than one target type per style. It's not a collection property, it's a single property. So what we're going to do instead is we're going to turn this style into its own static resource, just like the bitmap image, by assigning a key. And we'll call this calculator control, or calculator style. Okay. And we're also going to change the target type, because now we're not going to target a button, now we're going to target a control, which is a base class that's shared by the text box and the buttons. And then we have to actually take this and use it as another style that is going to target, again, the buttons. And then we can reference the other style with this based on property. So we can say we want to take the style from the calculator style and have that, which is a static resource. So we again have to do the curly braces, static resource, calculator style, and get rid of this extra bit here and close that off. And now you can see, again, the buttons can get that style and apply it. So they're setting all of their margins to match that margin. And we're going to do the same thing for any text boxes. So style target type equals text box. And we're going to set this based on and static resource and calculator style. And close that. And now notice that this also collapses. Now our text is still bigger than the buttons. And the reason it's still bigger is we're setting it here with a style. But then when we scroll down and look at the actual text box properties, we are overriding that with this font size of 50. So whatever the closer style to the actual element is the one that will be used when they have the same property. So basically, in this case, declaring it on the element itself is really the closest we could get. So we're definitely going to be using the 50 pixels instead of the 40 pixels that was defined in our style. But we also grabbed the margin because we didn't override that. Now we're applying that margin. So this is a really quick and easy way to style a lot of content without needing to do a ton of extra work. So the next thing I'd like to turn our attention to is implementing the actual functionality. Now most of this has already been done for us. If we jump to the code behind, we actually have, for example, an event handler for the onClear property for when a number key is pressed or when an operator key is pressed. What we don't have yet is these necessarily hooked up and actually functional. So if we jump in and take a look at our buttons, kind of the traditional way that we would do this is we'd go ahead and add a click handler, or listener, on each one of these buttons. So here, for example, we have the onClear event listener hooked up and ready to go. If we go and take a look at that onClear event listener, it's a pretty short one. Here it is. We are basically looking at a cached operation and setting that to none. We're setting the display text, which is the text box content, to be the digit 0. And we're setting this next key overwrites to true. These are all cached values that we've defined here as private values. So we have, for example, two operands. These are the two numbers we're going to do some kind of operation with. So 5 plus 3, 7 divided by 2, any of those kinds of things. We have an operation which is drawn from this operation enum, so add, subtract, multiply, divide, plus none. And we have this Boolean next key overwrites, which just determines if, when we hit a digit key, if we're going to replace what's displayed in the text box, or if we're going to just append a digit to it. And that's all these event handlers are doing. For example, on number press, we are basically looking to determine, do we need to overwrite the existing digit, and if we do, we replace that with what we derive from here, and otherwise we just append with what we derive from this button tag. There are a couple things I do want to talk about here in a little bit more detail. The first is this. This is the casting expression. So this is actually some syntactic sugar for something that we used to have to do. So when we wanted to take this sender, which is always an object, and know that it was a button, and we wanted to be able to access button properties, we have to cast it. So we could have, for example, just said var button equals button sender. So this is kind of the traditional cast operator that you've learned in the past. Now there is a problem potentially with this one, which is it throws an exception if this cast is not possible. Now, ideally, this event handler we will only ever attach to a button, but just in case somebody does attach it to something else, we can do this kind of test, if sender is button. And then inside here, we know that that sender cast is perfectly safe to do because we've already verified that this sender is a button. There's no other way we can get into it in here. And of course, with reference type, we could cast it that way, or we could use the as keyword. And in either case, we know this cast will succeed because we've already tested for it. Now, the developers of C# said, oh, we see this a lot, and there's actually, we could probably make it even easier. So they added this syntactic sugar, where we could declare a variable as part of this is expression, and then we don't have to declare it inside the body. So this serves the same role. This whole expression evaluates to true if the cast is possible and false if it isn't. But this variable now becomes defined inside this body and is of whatever type we specified here, and it is this variable cast to be that type. So that gives us that button to work with. So in here, we're just checking if the only thing we have entered is a 0. We usually don't have leading zeros in a calculator, especially this kind of calculator. So we'll just replace that 0 with whatever digit was hit. Or if this next key overrides is set to true, we'll also replace whatever is currently displayed with the new value. And so that's exactly what we're doing here. Now in the button, we have this tag property. And actually all XAML or all WPF controls have a tag. And so do all Windows Presentation Foundation controls. And it's probably something you've seen from that work. A tag is just an object that we can drop whatever kind of value we need into it. It's really there for the programmer, for our convenience, so that we can put something in it that we need to use. So for example, we're using the tags here to represent the numbers 7, 8, 9, 4, 5, 6, 1, 2, 3, and 0. So this one's missing one. To basically say these are the values we want to add. And we could just convert that to a string, and here, because we're appending it, converts it to a string. Whatever we put in there, of course, because it is technically just an object, we have to cast it as well. So ideally, we'd only use it that way. And then we can do something similar, or we do something similar for the operators. So we first of all check to see if there's a cached operator. And if there is not one, so basically we've started from a fresh state, maybe you typed in 2 numbers, 52, now you hit the plus operator, we would hit this branch of the if statement because we don't have a cached operator. And if that's the case, we are going to go ahead and set the first operand to be what's currently on our display. And of course, that's a string, so we have to parse it with int.parse to turn it into an integer. And then we're going to clear the display so that you're ready to type in the next number. And the last thing we're going to do in this method is we're going to take the operation, and in this case, again, we're doing some tag manipulation. So we take the tag, and in this case, it would be a number corresponding to one of those operation enum values. So we convert that to an integer, then we cast it, then we assign it. That's kind of ugly. We'll look at a better way of doing that in a moment. And then we also say, okay, now we need to overwrite the next key that's hit. So that's the first time we hit the operation. The second time we hit an operation button, we now have a cached first operand. So we come down in here and we cache the second operand, which again is parsed from the current display, and then we apply this operation. So this helper just looks at the operation and applies it. So if the operands were, if we're using addition, we add the 2 operands, we turn that into a string, we stick it back into the display. Same for minus, multiply, divide. We just perform the operation, stick it back into the display, and then we clear that cached operation, which means our display now has the result of that operation, and we go ahead and cache the new operation, so whatever button was pressed here, and then we go to the next key overrides, we set that as well. Okay, that's the basic functionality. Now, again, traditionally, if we were going to hook these up, we'd have to go in and add that click event handler to all of these buttons. You might be wondering, is there a better way of doing that? Well, there actually is. Just like we have the style here for our button, we could go ahead and expand this out so that we can have children in here. So just like we have a setter, we also have an event setter. And the event setter takes the name of the event we want to mimic, so in this case click, and the handler we want to invoke, and this will be on number press. Now, this by itself is not quite going to get us where we want to be, because if we go ahead and run this, we'll take a look, and we'll see how the functionality is working, and we'll also see where it maybe isn't behaving the way that we want it to. So now when we start typing our buttons, you can see the number part is actually working. It's working very well. But when we hit the clear button, for example, we crash. And if we look at where we crash, this is inside that on number press. So we hit the clear button, and we know that our clear button, we actually set the event handler we wanted right here in this click on clear. But an important thing to understand about event handlers is we can attach as many of them as we want to any particular event handler. So we actually have this event listener plus, because this is a button, we've attached the on number press event handler as well. So what we really want is we don't want to attach this to all buttons. We just want to attach it to these number buttons. So if these were, for example, defined in their own grid that was separate, we could define the style on that grid, and then it would only apply to those children. Unfortunately, in this case, these are all children of the window, all these buttons, both the operation buttons and the number buttons. So we need a different solution. Probably the easiest solution that we can do is, instead of using buttons here, replace this with some kind of custom control. So we can go back in and add, and we could do a user control and go ahead and create maybe a digit button. Okay, so here's our digit button, and we're really not going to do any changing of how it looks, but instead of overriding the user control, we really want this to be a superclass or a subclass of button. So we'll go ahead and make this a button instead of a user control, and I'm going to just take the grid out because I want it to just be exactly the button, nothing more, nothing less. And then we'll go to the code behind, and we need to make that same change here. So instead of extending from user control, we need to extend from button. And there we go. We have now a button, a digit button that is pretty much just the button. We haven't added anything new to it. We just overrode the default class. So now if we jump back to our main window, we could change all of these guys to be that particular kind of button. So a local digit button. And we'd want to do this for all of those. All right, and once we've made that change, we can come back up here to our style, and we're actually going to set this button back to being self-closing, and we'll create another style, and we'll set this one's target type to local digit button. And we'll go ahead and set its based on as well to be that same static resource calculator style. So now it will get all of the same styling as the calculator, and we'll move this event setter into that. So now only the buttons, which are digit buttons, are going to get this particular target. So again, we still have our buttons looking the same, and if we click on them, we can see the event handler is now attached. If I hit the clear button, it no longer is trying to run the digit button, nor are the operator buttons. Of course, our operator buttons are not actually hooked up right now. The next thing we need to do is we want to go back and hook up our operator buttons. And we could do something very similar. We could go ahead and place these with a local operator button. Let's go ahead and create a class for that. And even though before we went ahead and did the full XAML, we don't actually have to do the XAML because we're not actually doing any styling with these buttons. We're just using the default button. We could also do this with just a regular class instead of a partial class that has a XAML background to it. Let's call this an operation button. And in here, we would want to override the Windows.system.windows. System.windows. system.windows.controls is where the button is defined. So we can also, instead of using a partial class that has a XAML partial piece, we could theoretically just go ahead and override a regular button and just have a generic class doing the same. Now this is still inheriting everything from that button that can be used with XAML. We're just using kind of a shorthand form for that. And now if we jump back to our main window, we could change these to local operation buttons. Okay, so now we have our operation buttons defined. We could go ahead and add a style specific to them as well. So go ahead and do a style target type equals local operation button. And we'll go ahead and base it on the same static resource, calculator style, so that its buttons look just like all the other buttons we've dealt with. And we have an event setter in here, event, and set that click. And let's set that handler to on, that equals on operator press. Okay, so now those are hooked up and ready to go. However, notice that we haven't actually declared tags in these. We did on the ones above, except for the 0. We had that missing tag there. So we could go ahead and do a tag here, and if we did that, then we'd also have to put in the value from the enum that we were treating this as. But it would be a lot more convenient if we could just use that enumeration value. And because we're actually overriding this operation button, we actually could do that. We could declare a property that is public of type operation. And I'll just use the auto property syntax here. And we'll add a little summary. The operation this button performs. And we can save that. And now if we come back to the main window where we've declared these, we could actually declare what that operation is. So for example, the minus, we could do operation equals, and now notice it populates our options because it knows this is an enum and it knows that these are the valid operations for that enum. Let's go ahead and say the subtract for the subtraction, the addition for the addition, the multiplication for the multiplication, and divide for the division. Okay, and for the ones that we didn't specify, those are going to default to none, and we can actually, because that is 0, but we can also code that into our operation button as well, say that we want this default operation none, and that just reinforces that we do want no operation if we haven't specified one. And then we want to jump back to the code behind, because now we don't actually need to use the tag anymore. We can actually, instead of doing this whole convoluted piece here, we can actually just say button.operation. But in order to do that, instead of casting this to be a button, we want to cast this to be an operation button. So that's where that's defined. But we know that this should be an operation button, so anywhere we need to use the operation, we just use that value. And that will go ahead and hook it up and run it exactly the same way. We could do something similar here. Instead of using this tag for the button, we could go back to our digit button and add maybe a character that represents the digit and just assign that instead of assigning a tag. And then we could get it in the actual value that we care about and the way that we want it represented. In fact, we could go a step farther and we could have this setter also set the text content of the button to actually reflect whatever value we actually put in there. So it could be we would only have to say, for example, 9, and then it would show a 9 on the as well, without us having to specify that separately. So let's give this a try. If we say 5 plus 2 and get the equal sign, we get our 7. And if maybe we take that times 7 and then divide it by something, notice it gives us 7 by 7. If we divide that by 8, we'll get 0, which I'm not sure that quite computes, so there may be some errors in the logic back behind. But for the most part, it looks like it's working. We could spend a little time debugging, writing some tests, but this conveys what we wanted to get out of this, which was how we can use the tree that is implied in this build of the XAML to actually simplify writing these kinds of applications. So in this case, we were able to do a significant amount of work with only a few styles being applied. And that's really all I wanted to cover for today. So we'll go ahead and stop there. Have yourself a healthy time, and see you soon.